when I taught you equilibrium, I said that the definition of equilibrium is first, net force is equal to 0, and
Right.
second, net moment of force is equal to 0, or sum of all the anti-clockwise moments is equal to sum of clockwise moments, right?
Okay. Okay.
This was what the actual definition of equilibrium is, right? Okay.
Right.
Now, in this question, if this says that this entire plank is in equilibrium, it means that this condition should also be satisfied and this condition should also be satisfied.
Right.
Okay. Now, first of all, the condition of net force, this represents translational equilibrium as we have discussed.
Right.
Now, translational equilibrium. Okay. So if here you have 500 newtons of force in downward direction, 400 newton of force in downward, and 700 in downwards as well. Now, here you have almost 500 plus 400, 900, 900 plus 700, almost 1600 newtons of force in downwards direction. Correct?
Right. Right.
So, there must be someone or some of the forces which are acting in upwards direction whose sum is 1600 newtons. That's when net force is going to be 0 on the plank. Is this thing clear?
Okay.
Sure.
Yeah, ma'am.
Okay, so in this diagram we can clearly see that P and Q, okay, are the two normal reactions which are being applied by these triangles on this plank, so that this plank is in overall equilibrium, that is, it is in translational equilibrium plus it is in rotational equilibrium. So 1600 newton of downward force should be numerically equal to P plus Q in upwards direction. Is this
Right.
thing clear?
Yeah, ma'am.
Okay, so you have one equation as P plus Q is equal to 1600. This is your one of the equations. Now you have, see, now you have two variables. One is P, another one is Q. So when you have, if you have n variables in an equation, if you have n variables in an equation, then you actually need n equations to exactly find out the answers. So like if you have 2x plus 3 is equal to 0, then it means that you give x equals to minus 3 by 2 easily, because you just have one variable over here, and you have to find out the answer of one variable as well. In this case,
Right.
because you are having two variables, you need at least two equations in order to find out the exact value of P and Q.
Okay.
Is this thing clear?
Yeah, ma'am.
Now, this was one equation. Now, from where are we going to get the other equation? The other equation we are going to get is from this. Net moment of force is equal to 0. Okay? Is this thing clear?
Yeah.
Okay. So, now we are going to write moment of all the forces about one single point. That point can be any point from where you know all the distances. So, you can take P, Q, or these any of these points as your required, as your point about which you're going to write moments of force, any point. And I'll
Right.
suggest you to actually take either P or Q as the point about which you're going to write the moments of force. Why so? Because if you take P or Q as the points about which you're going to write the moments of forces, then you know what great thing is going to happen. You neither know P, you nor know Q. So one of these variables are not going to come in your equation. Why? Because when we studied moment of force, we studied that if this is the axis and the force passes through the axis, then its moment of force about this axis is 0,
Right.
because its perpendicular distance from axis is 0,
Okay.
right?
Yeah, ma'am.
Okay, so write moment of force about any of the points. So let's write about P. Okay, is this thing clear?
Yeah, ma'am.
Okay, now about P. This 500 newtons about P is trying to turn this plank like this, which is in anti-clockwise direction. Thus 400 newton is trying to turn the plank in clockwise direction. This 700 newton is trying to turn the plank in clockwise direction, and this Q is trying to turn the plank in this direction, anti-clockwise direction. Is this thing clear?
Yes, ma'am.
Sure. How did I find out that these are going to turn like this? I've done nothing. I've just taken head of the force and I've turned it about the point about which the body is trying to rotate. That is this P. Is this thing clear?
Yes, ma'am.
Okay. Okay. So here you have anti-clockwise moments and then you have clockwise moments, and now you have to simply apply net anti-clockwise moment is equal to clockwise moment. So when you're going to do this, you're going to have anti-clockwise moments as similarly what you did over here. You wrote anti-clockwise separately, you wrote clockwise separately. Exactly, I'm going to do that here. So I'm going to write here anti-clockwise. I can write it as first of all this 500 newtons, and then we have this green one when we do not know the value of this force. Okay, so about this P, the perpendicular distance of this 500 newtons from this axis of P is 1 meters. Is this thing clear?
Yes, ma'am.
1 meter, and then you have force like this. So 500 multiplied by 1 plus another anti-clockwise moment that you have is of Q, which has a distance of 2 plus 1 3 plus 1 4. So about from the axis the distance of Q is 4 meters. Is this thing clear?
Right. Yes, ma'am.
So Q multiplied by 4. Okay,
Okay.
then this is your anti-clockwise moments, and then when you write clockwise moments, then you have clockwise moments this. Okay, 400 newton is going to give you clockwise moment, which is at a distance of 2 meters from your axis which you have chosen. So it is going to be 400 multiplied by 2. Is this thing clear?
Yeah,
This
ma'am.
was 2. Okay, and then you have 700 newtons like this. So 700 is at a distance of 2 plus 1, that's equals to 3 meters. So 700 multiplied by 3. Is this thing clear?
Yes, ma'am.
So you're going to have 500 plus 4q is equal to 800 plus 2100 when you equate both of them. Is this thing clear?
Yes, ma'am.
That's what I have done, the same thing that you did in the earlier question.
Okay.
Fine.
Yes, ma'am.
Okay, and from here you can find out the value of Q and then substitute this value of Q in this equation, and from here you're going to get P as well.
Okay.
Is this thing clear?
Yes, ma'am.
Okay, do you want me to calculate it right now?
No, no, it's fine. I can do it.
Okay, so whatever value you're going to get from here, you just substitute it here. So this question was a bit different, and as compared to other questions, this was a bit difficult as well. So while revising this chapter, I think I'll suggest you to do this question as a must for revision, because this is conceptually a very good question.
Okay.
Okay, is this thing
Sure.
clear?
Yes, ma'am.
Okay. Next, third was correct. Third was correct. Absolutely correct. Okay. And actually, when notice this one thing, did you directly write m multiplied by 50 is equal to 100 multiplied by 40?
No, ma'am, I saw it. I saw the
No, no,
equation.
yeah, yeah. You undoubtedly saw it from the figure. But was this the equation which you first wrote? Like, this was the equation which you directly wrote, or you wrote some other equation before this equation, and ultimately you got this equation on doing some manipulations in an earlier
Oh,
equation?
directly had this.
You directly had it. Okay. The problem here is this m and this 100, these are masses.
Right,
Okay. And when you talk about moments, then you talk about forces. So you had to take care of weight. You had to take weight of this m and weight of this 100 grams. And then actually it should be something like this: weight of this m is going to be m multiplied by acceleration due to gravity, and weight of this 100 grams is going to be 100 multiplied by acceleration due to gravity. Is this thing clear?
right.
Because whenever we write anti-clockwise moments is equal to clockwise moments, and whenever we write moments, we write moments of forces. So actually you have force as mass multiplied by acceleration due to gravity, and you have force as 100 multiplied by acceleration due to gravity, and then you take mg multiplied by 50 should be equal to 100 g multiplied by 40. And then these g's are going to cancel out, and then you are actually going to have m multiplied by 50 is equal to 100 multiplied by 40. This was not required in this. Fine.
Okay,
But we actually did this thing here over here, because if we don't do this thing, then we are going to be conceptually wrong.
right.
So can you tell me, like, what exactly did you understand in second question? Once again, just once again.
Second question, is it?
Yes, second question. Like, what is the approach that you understood that we should apply in these type of problems?
So you're basically adding up all the down forces,
Yes, I'm adding up all the down
which equals
forces.
to the forces that are applied upwards.
Great. Okay. So that's the first equation. Fine.
Right.
Because that's the first condition of equilibrium.
Yeah.
Okay. And
And then
then what
the
about second?
net moment of force is equal to zero.
Net moment of force is equal to zero. And like, how did I choose about which? Because while writing the force, I need some axis, right? Oh, sorry. While writing moment of force, I need some axis about which I need to write moment of force.
I'm sorry, ma'am, I didn't
Yes.
get that. Could you repeat again?
I'm saying that for writing moment of force, I
Right.
need a point about which I'm, writing the moment of force, so that I have fixed distance of every force from that particular point.
Oh,
So how did I choose that? Because in this question, like, I chose P.
because
How
the
did I
distance
choose
from
this P? Or you can choose anything, obviously. Like, why did I choose P? And like, what after that? What did I do? Just tell me that, like, just the method. Your first part was absolutely correct, from which we get this equation. And then what about the second part?
second part is basic. One second. I've written the notes, ma'am. Just a second.
Hmm.
Yeah. 500 plus 4q. The 4q is because the distance on both the sides of the q.
Distance on both the sides of?
The q. So there's 2 on one side of the q and there's 2 meters on the other side of the q. And then
I
500.
I did not use this at all. This was not required. This distance was not required. um Wait, I'll just tell you again. all I have to do is I have to choose a point about which I'm going to equate all the clockwise and anti-clockwise moments. Okay?
P,
That's what my aim is. Okay?
P,
Yeah. And I chose this as my point about which I'm going to write all the clockwise moments and all the anti-clockwise moments. Is this thing clear?
P. Okay.
Okay. Now, about this point P, this this force gives anti-clockwise torque or clockwise torque or moment of force. About this P, what is the direction
Anti-clockwise.
of moment? Anti-clockwise. Great. Anti-clockwise. About this P, this force gives clockwise moment or anti-clockwise moment?
Which one, ma'am?
This 400 Newton.
That is clockwise.
Clockwise. Okay. Correct. Then what about 700?
That is also clockwise.
Hmm.
Clockwise.
Yeah. Correct. Clockwise. And what about Q?
Uh, Q is anti-clockwise.
Anti-clockwise. Okay. Now, about P, what I have to do? I have to equate all the clockwise moments is equal to all the anti-clockwise moments. That's what I
Right.
have to do, right? That's what my
Right.
aim is. Okay? Okay. So can you tell me the equation of anti-clockwise moments? All the anti-clockwise moments
Equation. Uh,
of all the anti-clockwise moments.
500 plus 4Q.
500 and perpendicular distance, because moment of force is force multiplied by perpendicular distance, right?
Yeah. So 4 because it's
500 multiplied by 500 should be multiplied by something, right? Moment of any force is equal to force multiplied by perpendicular distance.
4, ma'am. Distance from P to Q is 4.
Not P to Q for 500. I'm writing first for this, right?
Then 2. The whole area. The 2.
If this is my force 500 newtons and
500
this is point
Newton.
P and this is length, this length is 1 meter,
Okay.
this is the force, then what is the perpendicular distance
From 500 to P,
from P? What is the
that is 1 meter.
500 distance? That's, yes, that's 1 meter. Therefore, anti-clockwise torque is going to be 500 multiplied by 1. Is this
Right.
thing clear?
Yes, ma'am. Yes, it is.
Plus, what is the other anti-clockwise force that we have?
Just a moment. 500 plus 1. The Q.
Q. Okay, great. So Q should be multiplied by what is the perpendicular distance of Q from P?
4.
4. Because this is the perpendicular distance. Okay?
Right.
4. And what about the clockwise equation? All
Clockwise,
the torques, what are the all the moments of forces on the clock in the clockwise direction?
400 and 700.
400 is force. And what's its perpendicular distance from P?
2 meters.
Correct. Plus, what about the other one?
700, 700 times
700?
3.
3. Okay. And then what we have to do?
Just a second. I'm 400 times.
If this is your anti-clockwise movement and this is your clockwise movement, now what do you have to do?
Add them up. Or rather, equate
Add
them.
them. Equate them. Yes, equate them. All the anti-clockwise moments are going to be all equal to all the clockwise moments. That's when net moment of force is equal to 0. Okay?
Right. Yes, ma'am.
You do this question once again and send me, okay?
Sure.
Okay. Last question. Let's discuss it. Okay.
Yeah.
And it's not very actually tough. Also, the last question. Figure 10.8 shows three positions of the pedal on a bicycle, which has crank 0.2 meter long. Fine. If the cyclist exerts the same vertically downward push of 25 newtons with his foot, in which in which case A, B, or C is the turning effect, this and this, explain your answers. So see, first of all, in these cases, okay, 0.225, in all these cases, you do not have to pick the answer. This was not pick the correct answer type of question, okay?
Oh,
This
okay.
was not that. This was, you have to mark which moment of
Which is
force corresponds to
basically like
which
match
picture.
the following type.
Yes, match the column type. Okay, is this thing clear?
EAB, right? Yes, ma'am.
Hmm. Now, can you tell me? Just forget about the options. Okay, forget about the options for the time being. Can you tell me what what is the moment of force in each of these diagrams? Like in A, what is the moment of force? This is your force. This is your axis. This axis. This is your force. This is your axis. What is the moment of this force about this axis?
Times force times the perpendicular distance. So what is the distance?
Okay,
Point
force
0.2
times
meters.
perpendicular distance. What is the value of perpendicular distance? Forces in every picture, forces 25 newtons.
Yeah, so then distance is point 0.2, even that is permanent, right?
Distance is point 0.2. The length of crank has been provided to you as point 0.2. That is
Oh, that's not the
this
distance though.
length, this length is point 0.2
Yeah.
meters. Okay.
Perpendicular
Now
from the
tell
post
me
to the
what,
chain.
yeah?
Perpendicular from the post to the chain, right?
No, force is being applied on the pedal.
Right.
Force is being applied on this pedal.
Okay.
Like these arrows have been given to you for that case.
Got it.
Okay.
Hmm.
Now tell me that what is the moment of force in this A?
Zero.
Force multiplied by, you have to simply use force multiplied by perpendicular distance as
Perpendicular
your
distance.
formula. Right.
Zero.
What?
There's no
Zero.
distance
Correct.
per se, right?
Why? Why zero?
The distance isn't like
The force passes through axis, as
distance
simple
is
as that.
yeah. So it's just
Yeah.
one line.
Whenever the force passes through axis, the perpendicular distance is zero, because basically you cannot drop any sort of perpendicular in that case on the force, on the line of action of force.
Right.
Right? So in this case, the answer is zero. What about this? C.
Just a second. I'm trying to. Okay. See.
This is your axis, this is the force.
Oh, there is distance.
Yes. Here there is distance. So what do you think should be the moment of this force?
25 times point 0.2.
Yes, absolutely correct. 25 times point 0.2. Okay.
Right.
That's going to be 5 newtons. Oh, sorry,
Right.
5 Newton meter. Right?
Right.
Now, what about this? So
That's the
for
remaining.
that's, yeah, that's the remaining, but we have to explain our answers
Yeah.
as well. We
Right.
cannot
Right.
we cannot just write that, okay, that's the remaining part. Okay. So for second one, for zero, the answer is A. For first one, the answer is C. And what about this?
Just a second.
Force is this. This is your force.
Yeah.
This is
So if
your
the C1
axis.
is point 0.2, the distance comparison between C and D is a bit lesser than point 0.2, right? So
Okay, you are calling this as point B?
yeah.
Sure.
No, B in the sense I meant the question number B. I didn't mean to
Okay,
call any
question
point.
number B. Okay. Okay. Yeah. So this is your force.
Right.
This is your force. And I think line of axis of force is this entire line is the line of axis of force,
Right.
and this is your axis about which you have to write the torque or the moment of force. So
Okay.
if this is 25 newtons, then what should you take as perpendicular distance?
I can't take point two, right, ma'am?
Yeah, point 2 is this length. Point 2 was given to you as this.
Yeah.
This is point 2. And you have to take perpendicular length, perpendicular distance. Can you just tell me what is the perpendicular distance?
Oh, not quite sure, ma'am.
Not sure?
Oh,
Okay. Mm-hmm.
right
Try.
angle.
If this is your force, okay, I'm not going to draw force as this much long because force is only up to here. If this
Right.
is your force and this is your axis,
Right.
and you have to write the moment of this force about this axis,
Right.
okay,
Okay.
then this line, I'll just dot it out. This line is first of all line of action of force. The straight line which passes through your force is the line of action of force.
Okay.
Yes or no?
Yeah. Yeah. Got it.
Okay. So from axis you have to draw a perpendicular distance
Right.
from your axis. So if this is the line and this is the axis,
Right.
then perpendicular distance should be this length.
Okay.
Yes or no?
Yeah.
Sure?
Yeah, ma'am.
Okay. And therefore, if this is zero point 0.2 meters, if this length is zero point 0.2 meters, then this length is definitely going to be some number which is less than zero point 0.2 meters.
Right. Got it.
Okay?
Got it.
How did I do that? Because this is basically the base and this is the hypotenuse. Okay?
Yes, ma'am.
So this is going to be something less than zero point 0.2 meters. It might be 0.15, it might be zero point 0.1. I don't know. It totally depends on
Anything.
this angle.
Fine.
Is this thing clear?
Yeah, ma'am.
Okay. So in this case, if your minimum moment of force was zero, why? Because in this case, perpendicular distance was zero. So your minimum moment of force about this axis was 0 Newton meter. And in this case, the maximum amount of moment of force was there, which was 5 Newton meter. Why? Because here the perpendicular distance was zero point 0.2 and here the perpendicular distance is 0. So if for this case you are going to write down moment of force, if for this case you're going to write down moment of force, then it is going to look something like this: force multiplied by perpendicular distance, where perpendicular distance is something which is greater than 0 meters but less than zero point 0.2 meters. Yes?
Great.
Okay. So if in this case you are going to find out moment of force of 25 Newton meter is 25 newtons, then it is going to be 25 multiplied by 0 is less than 25 multiplied by whatever the actual perpendicular distance is. This is your moment of force for B. Moment of force for B less than 25 multiplied by uh, 0, and then less than 25 multiplied by zero point 0.2, because that was the maximum distance, and this was the limit of your perpendicular distance. Is this thing clear?
Yeah, ma'am.
And therefore 25 multiplied by 0 is 0. This is your moment of force.
Right.
Moment of force for B,
Right.
and less than 25 multiplied by 2,
Right.
which is 5 Newton meter. And therefore in this answer, this is for B. This is your explanation for this particular answer. Is this thing clear?
Right. Yes, ma'am.
So how are you formally going to write it in your exam? You are just going to write it like this. First of all, for A, you write, because force passes through axis, therefore perpendicular distance of force is 0. Since force passes through axis, perpendicular distance, I'm using the symbol of perpendicular, you have to write full perpendicular in your exam.
Right.
Force passes through axis, perpendicular distance of force is equal to 0. Okay. And
Right.
then for B you are going to write force multiplied by perpendicular distance, but you have to clearly tell that this is the perpendicular distance. This is the perpendicular distance. This you have to clearly mark in your exam. Okay.
Right.
And this distance is definitely less than zero point 0.2 meter, because zero point 0.2 meter is hypotenuse, and this serves as base if this is the angle. Is this thing
Right.
clear? Okay. And then you have to write down this inequality.
Okay.
First you will write this, because your this 0 meter greater than perpendicular distance is greater than 0 meter but less than zero point 0.2 meter. Then you have to write down this inequality, and after that you are going to write this.
Right.
Is this thing clear?
Yes, ma'am.
Okay. And then finally you are going to write this as your final inequality. Fine.
Yes, ma'am.
Okay, so this is your for second, and for third part, that is C. For C, the perpendicular distance is very clear because your force is like this. And yes, in all the question, do make line of support, a line of action of force. That is this line, because perpendicular distance is actually measured from the axis to the line of action of force. Always draw the line of action of force.
Right.
Is this thing clear?
Yes,
Okay.
ma'am.
So I'll suggest you to, do actually not just second, do second and fourth problem, and write fourth in proper language as well, so that you can understand how to explain your answer correctly in the paper.